For the demonstration, we could fuzz any type of library that comes to mind. And I didn't have anything specific that came to mind, so I thought, well, let me just fuzz a simple MSDN, a Microsoft Windows function. For example, message box function. Suppose there's some kind of a program, and this again could be any kind of function, and somehow I'm able to deliver data that roundabout later on gets passed to this function, and instead of interfacing with the entire system or the entire program, I think, well, let me just test individual functions and see how they hold up against various types of malicious, out of range, long, whatever types of fuzzed inputs there might be. So you need to know something about the function to be able to do that. You need to know the library that it lives in. And typically on any MSDN page, if you scroll to the bottom, it'll tell you that. And we see the code library that it exists in, user32.dll. The other interesting way, and we haven't got to reverse engineering, that's in the class that'll be a whole nother class that'll be coming later, but we could use a tool called IDA Pro to inspect different functions within a code library as long as they have some public symbols, and for message box they do have public symbols. So even if we couldn't find a documentation page on this function, we could even figure out how the function operates through reverse engineering instead of just reading the documentation. And sometimes that's not a bad idea because sometimes the documentation is not exactly in sync. So as I said, I've modified a slightly older version of Peach 2.3 to do API fuzzing, and we'll look at the bottom here first. The output goes through the run directory, so crashes would go to a normal location, just as always, to the disk. And this is the interesting bit here. In the past, we were using file publishers. In this case, we're actually going to use a DLL publisher to touch this message box API, and then we select just certain mutators we want to run. And then we have a state model that shows how we're going to call this function. And of course, the most important part, as usual, is the data model, where we specify a number, a string, a number. We basically tell Peach how we're going to fuzz this, what type of data and what type of mutations we need to do on that data. So let me go ahead and just give it a run. And what's interesting about this one compared to some others is we have a helper program called the pop-up killer. And that's just a Python program. I won't go through everything about how it works because it would take a little while to explain this whole thing. But basically, you look for a certain caption or a certain message window to pop up with certain text, and then you can tell it to kill those particular windows. Because if you just tell pop-up killer to kill every window on your machine will close down. So why do I need to kill windows? What am I even talking about? What's this pop-up killer thing all about? You'll see when I run the fuzzer what I'm talking about here. So let me just go ahead and run the pop-up killer first and go ahead and run the fuzzer second. So as we see the fuzzer run, you'll see those message boxes coming and going. Sometimes it's hard to see them. They come and go so fast, but the arguments to the function are getting mutated and changed, and the pop-up killer is clicking OK on each window that pops up so that the fuzzer can carry on fuzzing. And that's basically the essence of a simple API fuzzing tool. In summary, we talked about the differences of regular fuzzing and API fuzzing, and where it may or may not be good to use API fuzzing. Again, typically those hard to reach places or complicated functions that may be difficult to get to because of the external interface might get in the way of that. Coming up next, we'll talk about a very similar technique called in-memory fuzzing, and that's a situation where you don't have ready access exactly to the source code, but you still want to do something like API fuzzing. We'll talk to you next time.